The min or max value of a function is the y value located at the x value, and that is a little bit confusing. So let's take a look at example 4. And with example 4, we have a graph, and I'm not even going to try to draw it accurately, but it looks kind of like that. Okay, the general shape of the graph. So let's say we've got this point here. We're going to call this the point -2, 4. It does go through the origin, and then we have this point 2, -4, and then up here we have the point 7, 8, and we're calling this point R, this point P, and this point Q. So it says the graph of a function is given. Find all local min and local max values and where they occur. All right, so let's take a look first at point P. Point P is what? A local min or a local max? Well, it isn't the maxest, is it? It's not the biggest point, but locally it is a max, meaning just in that small region, it is a local max. And the local max is 4, that's the y, and it occurs at x equals -2. So when you say is, that's your y. Where it occurs at is your x. Confusing, just kind of different. Let's look at point Q. Right there. Point Q is a local min, and it is -4 at, it occurs at x equals 2. Remember the at is x equals. And finally, we have point R, which is right here. It's another local max, and it is 8, and it occurs at x equals 7. Do you see how you record that? You just have to learn the language. That's all it is. Okay, it says use a graphing utility to approximate local maxima and local minima and to determine where a function is increasing or decreasing. So in example 5a, we have this function. The function f of x equals 6x cubed minus 12x plus 5. So you're going to put that into your graphing calculator. So I'm going to try to do this and write and talk all at the same time. You're going to go to y equals, make sure everything is cleared out. Look above that, plot 1, plot 2, plot 3. Make sure they are not on. If they're on, one of them will be highlighted. If it's on, you need to turn it off. So we're going to type in 6x cubed and then minus 12x plus 5. Hit enter, and now we need to set the window, and I actually included the little window there, so go up to window, and we're going to set it at -2 to 2, scale of 1, -4 is our y min to 30, now change your y scale to 2, now hit graph, and you're going to see your graph. I am not going to attempt to draw it. I'm assuming you have your graphing calculator in front of you and you have drawn it. And now we want to know where the local min and the local max are, and then where it's increasing and where it's decreasing. So I want to show you how you do that on a graphing calculator. So it says use your graphing calculator to determine the local max and local min by pressing second trace and then selecting number 3 for min or 4 for max. So go up and do second, your blue key. Trace is up at the top. And you notice it goes value, 0, min, max, intersect, etc., etc. So I want you to hit 3 for min. Now, this is how it works. It wants to know which min are you talking about, because maybe there's more than one. On this particular graph, there's only that one that we're talking about. So get your cursor to the left of that minimum point. It should have popped up there. And it says left bound. Go ahead and hit enter. Now it says right bound. Use your right arrow to right arrow over till you are past where that min is. Past the min, and then hit enter again. And then it says guess. Okay, we never play guess, so we're going to hit enter again. We're not going to guess. And it's going to show you that point. It's kind of hard to see because the writing's almost on top of it. And it says minimum. And it has this. X is 8.16. I'm going to round it off and leave it at that. Y is negative 1 point, hard to read, but I think it's 5.3. So it's actually telling you what that point is. Okay? Now let's do the same thing for local max. So go back and do second, trace. This time hit 4 for your max. Now it wants to know left bound, right bound again. But notice where it is. It's where you left it. It's over on the min. So you're going to have to hit your left arrow and go all the way back. It's going to take a little bit to the left-hand side of that max point and hit enter. Now hit your right arrow till you're on the right-hand side of that max point and hit enter. Again, we're not going to guess. It's going to tell you now that that max is the point negative 0.816, okay? And then the y is 11.53. That's your local max. Now, we want to know where it is increasing and decreasing. That's a little harder because you actually have to look at it. It's not going to tell you that. And by the way, I'm going to round these two off to 0.82 and negative 0.82, okay? The local min and max, because that'll make it easier when we do the increase and decrease. So let's go back to our graph. Just hit graph again and it'll take away all the writing so you can actually see it. All right, now remember what the coordinates are for the min and the max point. So we want to know, where is it increasing? Well, it starts increasing, it looks like, on our graph. It's hard to tell. But because we set our window at x being negative 2, that's as far as we can say we know anything. So it's increasing when x is negative 2. It's going up, up, up. You see it going up. Where does it stop going up? When it hits that max point, when x is negative 0.82. Now, is that the only place that it is increasing? No, it's also increasing. So union with, where does it start? It starts at the min point. And that was when x was 0.82. And where does it go to? Well, our graph only goes to 2, so that's as far as we're going to say. We're not going to go infinity there. All right, let's do decreasing. It's decreasing when x is from the max point down to the min point. That's the only place it's decreasing. So from the max x, which is negative 0.82, down to the min point, which is 0.82. So that's the interval that it is decreasing on. All right, let's look at the back, and here we're talking once again on average rate of change. I'm going to abbreviate that. Average rate of change. It says the average rate of change of a function between a and b is the slope. Average rate of change is the same thing as slope of the secant line between a, f of a, and b, f of b. Ooh, that sounds so complicated. So let's look at exactly what that means. I have a graph on your notes that looks something like this. Okay, let's extend that. So I have some point. We're going to call this point a, f of a. And we're going to call this point the point b, f of b. That would be my y. The secant line is the line that connects those 2 points. So we know that this point right here, to get there, I went over a distance of a, and then I went up a distance of f of a. So over here, I can call that f of a. For this point, I went over a distance of b, and then I went up a distance of f of b. So over here, this is the point f of b. Okay? So it's saying that the average rate of change is equal to the change of the y's divided by the change of the x's, which is just f of b minus f of a over b minus a. Well, does that look familiar? Because it should. I can call f of b y2. I can call f of a y1, which makes this x2 minus x1. And what do we have? We have our slope formula, y2 minus y1 over x2 minus x1. It's just a different way to say it. It's the function notation way. It's the average rate of change way to say it. So it's the same thing. And by the way, we know that a cannot equal b, because if so, you would have a 0 in the denominator, and we would be talking about a vertical line. So let's look at example 6a. Find the average rate of change of f of x equals 3x squared, and then we're going to be going from 1 to 3, so between those 2 points. So here's what we have to know. I'm going to do this in the margin. I have to know that this is my, I'm going to call this my A, and this my B. It's the same thing as saying x1, x2. Alright? So I have to know that f of x is 3x squared. So what else do I need? I need f of 1, and I need f of 3. So let's find f of 1 first. That would be 3 times 1 squared, which is just equal to 3. F of 3 would be 3 times 3 squared, which is 3 times 9, which is 27. So what it's really saying is I have these points, the point 1, comma 3, and the point 3, comma 27. That's how you've been doing it up to now. This would be x1, y1, x2, y2, and you would follow the formula. But we're going to use this new rate of change way of doing it. So it's delta y over delta x, which is f of b, or f of 3, minus f of 1 over 3 minus 1. Well, we just found f of 3. That's 27. Minus f of 1 is 3. Over 3 minus 1 is 2. 27 minus 3 is 24. Divided by 2 is 12. We would have gotten the same thing here. 27 minus 3 over 3 minus 1. You get the same thing. It's just a different way to look at it. This is our slope, or our average rate of change. Slope. Same exact thing. It's 12. Okay? Now let's do the same little experiment, but instead of going from 1 to 3, we want to know from 1 to 5. So here's our A, here's our B. F of A is f of 1. Well, we already found that over here. F of 1 was 3. F of B is f of 5, so that would be 3 times 5 squared. Or f of 5 is equal to 75. So now I can say that delta y over delta x is equal to f of 5 minus f of 1 over 5 minus 1, which is equal to 75 minus 3 over 5 minus 1 is 4, which is equal to 72 over 4, which is equal to 18. So the slope of the line between 1 and 3 would be 18. It's different than between 1 and 3. Because this is a curve. My function is a curve. If you want, pop that into your graphing calculator and see what that looks like. It's a parabola. It's not a straight line. That's why the slope isn't constant. It changes. Alright? Finally, I think I can fit C on here. Let's do C. We want to know what is that slope. What is the average rate of change from 1 to 7. Here's A, here's B. I need to know f of 1. Well, we already know it. It's still 3. I need to know f of 7, which is 3 times 7 squared. 7 squared is 49, times 3 is 147. So my delta y over delta x is equal to 147 minus 3 over 7 minus 1, which is 144 over 6, which just happens to be 24. So we found our average rate of change, or our slope, depending on which part of that function you are talking about. All right, let's go to example 7. It says, suppose that g of x is equal to 3x squared minus 2x plus 3. 1, part A, find the average rate of change of g from -2 to 1. This is A, this is B. All right, we can do that. That means we need to know f of A, and then we will need to know f of B. Well, f of A is f of -2, and f of -2 is equal to 3, take out the x, -2 squared, minus 2, take out the x, put in a -2, plus 3. I'm just putting in my -2's there for the x. That gives me 3 times 4 plus 4 plus 3. That's 12, and 4 is 16, and 3 is 19. Okay, that's f of -2. F of B will be f of 1. Now, this is a different function this time, so f of 1 isn't 3 anymore. So it's going to be 3, take out the x, put in a 1 squared minus 2 times 1 plus 3, or 3 minus 2 plus 3, which is 4. All right, so that is 4, and f of A is 19. All right, so now we're ready to start. So delta y over delta x is f of B minus f of A over B minus A, which is equal to f of 1 minus f of -2 all over 1 minus a -2. It's supposed to be g, sorry. These are g's, g's, g's. I'm stuck on the f's, doesn't matter. Which is equal to, what is g of 1? We just found it. It's 4. Minus, what is g of -2? Minus 19. All over 1 minus a -2 is 3. So we have 4 minus 19 is -15 over 3, or we have -5. And what is that? That is the slope of the secant line. Remember, a secant line joins 2 points. And what points are we talking about? We're talking about the points -2, 19 and 1, 4. The slope between those 2 points is -5. It's just new language for old stuff. Let's look at B. Find an equation of the secant line containing -2, g of -2, and 1, g of 1. All right? What is that really saying? Well, remember, we found, although I used f's, we found g of -2 right there, and we found g of 1 right there. So we're really saying, what's the equation of the line that contains the points -2, 19, and the points 1, 4. So we can do it 2 different ways. We can do it with point slope formula, or we can do it with slope intercept formula. Now you know which one I like better. I like slope intercept, but we'll do it both ways for those holdouts that I might have. So let's look at what we have. We need an x and a y. We just found m. It's -5. Which x and y do you want to use? I'm going to use 1 and 4 because I think those are easier. So I would go for point slope y minus y1 equals m times x minus x1. Now distribute. Y minus 4 equals negative 5x plus 5. We're going to solve that for y by adding a 4 to both sides, and I get y equals negative 5x plus 9. Okay, I have to admit, it was kind of easy that way. Let's do it slope-intercept way. Here, I need an x and a y and an m and a b. The m is negative 5. I'm going to use the same x and y, the 0.14, and I would say y 4 equals m x plus b. 4 equals negative 5 plus b. Add a 5 to both sides, and I get b equals 9. Therefore, y equals m that I found, x plus b. We get the same thing as we did using point slope.